Today we're going to be installing and testing the Spetools Router Lift. They sent this to me for free in exchange for a review. Now you may have seen that we did set up a DIY version of a router plate and a router dust box previously on the channel. You can check out the videos at the top here if you want to see those. This is quite a significant upgrade from the DIY setup. I've been quite happy with the DIY setup, don't get me wrong, but with the Spetools Router Lift it will accommodate from a 2.5-inch router all the way up to a 4.2, which is kind of like I think like 2.4 kilowatt spindles, which are really big. For this review I'm going to be using the DeWalt trim router, which will fit into the router lift. Obviously if you've got something like what I've got here, which is the Triton router, a lot of these plunge routers, they are kind of in a molded plastic design. They obviously won't fit into a dedicated router lift, so you do need to bear that in mind. You do need something that has a cylindrical spindle body. You get everything you need to get this set up and working. They do include 2 jigs. You've got an outer and an inner contour jig, which is very handy. I've obviously got a hole cut in my workbench already for my DIY router plate, but it's a little bit too small, so I am going to need to just widen it up a little bit, so we will be using these. So let's jump into it. Let's get this thing installed. So you can see that the recess that I've got currently cut is actually wide enough. It's actually a bit too wide, but the width ways we do have to just take off this little bit here. So what I'm going to do first of all is I'll get this aligned, and then we do actually need to machine a little bit of the bottom lip here. Now you would normally cut the bottom lip first, you'd go all the way through, but you can see that if I put this down, I don't actually have any material for this to actually rest on, and it's actually too small to get in. So when we widen this up, just by taking this little bit off here, I should be able to drop this in, and then I can use that to cut the inner contour, which will go all the way through. But I thought it'd be interesting to show you because yeah, some people might already have a setup like what I've got if you're doing an upgrade. So we'll stick this down and then we will get this edge cut off here. Normally you would obviously cut the inside fully through first, because you're going to have the issue that I've got now where I'm going to kind of need a little bit of a long reach flush bit, router bit to get down here and keep it on this level. So yeah, I need to hunt around and see if I've got something that can do a long reach. Worst comes to worst, what you can do is you can just trace this line here. And because you actually won't see the actual inner cut because the plate is going over the top, I mean, you could just do this inner bit with a jigsaw, or you could just freehand it with a router, so it's not too much of a problem. So we'll just do a quick test fit. Okay, there we go. So that is fine. Obviously this is at the wrong depth. So what I've got is just some 3D printed riser blocks here. And then thankfully with this setup, you have grub screws. So you can adjust the height and get it level as well. Here and here. I probably need to glue these in on this side. And then we can just raise it up with the grub screws now, and that will be perfectly flush with the rest of the table. So I've got these stuck down now onto those plastic. Okay, so I'm just going to make sure that I can see a bit of metal through all of these grub screws. Right, so we've got the table kind of set in place now. I've just got 4 wood screws with some washers on here. Normally it would obviously be bolted through the table, but with my setup I can't do that because I've got a dust box going underneath it. What I'm going to do now is I will back off these screws, so we've got a little bit of height adjustment, and then we'll put in these grub screws which will make contact with these metal plates, and that's what we'll be able to use to make sure that we've got this nice and flush with the rest of the table. It's very easy to get set up. I've got it now, as you can see, I've got it flush on all sides. Using them grub screws is a really nice way to get it perfectly level. In the Spetool tutorial they have the grub screws. It appears like they are just making contact with the wood. Now my assumption is that if you do have a heavy router on the back of this, it is going to pull down. I do think those grub screws with the small contact surface area is probably going to dig into the wood over time, so you probably will lose the alignment that you've got. So I do recommend getting maybe some like metal shim stock or just some metal that you can place so that is making contact with the grub screw, so it will spread that load and it won't dent into the wood. There's not much else to do now. I just need to fill in this gap here, and then we can attach the router to the bottom, and we'll give it some test cuts, and we'll check out the mechanism for locking it and moving it up and down. I've got my router in there now, so we can use the up and down mechanism. It's nice that we just have access to it straight away on the table. With obviously the previous setup with the Triton, you have to kind of push the rod down through to make contact with the screw mechanism. This is really nice because it's just kind of on and off right here, and then when you've got it in position, you can go ahead and you can just lock it here so it won't move. Also with the package you get these magnetic dust ports as well, which just sit on top. And these allow you for obviously different size router bits to make sure that you've got adequate dust collection. We're just going to test how accurate this dial is here on the adjustment for the up and down. It's marked in inches, and the major graduations are 0.01 of an inch. So that should be, I think it's 0.25 millimeters. So we've got this set to 0. So if you move this to the 0.01 inch graduation, we should see this come round to about 25. So let's just give it a go. We'll just move it around. We've got about 0.23 millimeters movement there. So it doesn't exactly seem to be 0.01 of an inch in terms of the movement. Let's try moving it to 0.02 of an inch. And we'll just see we get around about the same, so this should be about 46. Okay, so we've got 0.47 millimeters movement here, which is getting a little bit closer to 0.02. Let's move it to 0.4, and let's just see what we get. That is near enough giving us 1 millimeter of movement there. If we bring it round to a full rotation, which is 0.05 inches movement, we get 1.255. That should be 1.27 millimeters. So you can see that we're off by a few hundredths of a millimeter, which for woodworking, I would say that is definitely acceptable. If we now wind this back to 0, we can just see what kind of backlash that we've got. So let's give it one full rotation back to 0. And then it looks like the backlash is about 0.025 millimeters backlash, which again is very, very small. And I mean, that could probably be tightened up by adjusting the brass nuts at the bottom. Now, I've never personally needed to worry about hundredths of a millimeter when I am doing woodworking and I'm putting in joints and things like that. I mean, it might be worth picking up maybe a digital height gauge. I think that would give you probably the most accurate way to set the height, but I would still be confident in going off of this dial. It's a shame that they don't give us Europeans and also Australians and other parts of the world a millimeter dial. I might actually make my own here because I never work in inches. Last thing I wanted to do is just test if there is any movement in the lift when taking a little bit of a deeper cut. So I set the height to 5 millimeters and we took the cut. Again, come back, measure it, and yeah, it looks to be pretty much spot on. Hasn't really moved, and that is with the lift in the unlock position. Obviously, if you are taking, bigger cuts, you've got a heavier motor, for instance, you'd usually probably want to lock the lift when you're taking those cuts. One thing I did forget to mention is that you do actually get a guide pin with the package as well. So I think overall, this is, a pretty good deal. I mean, you get the lift, which is a very robust design. The linear rail setup for the clamping mechanism for those larger spindle bodies is super heavy duty. I don't think you can have any issues clamping any type of weight of router. My only criticism is that on the website it says 0.001 inch precision, but actually the dial on here is 0.01 inch precision. Not too much of an issue. I think 0.01 inch precision is probably more than enough for woodworkers. The dial was a few hundredths of a millimeter out, but again, it's not that much of an issue with crucial cuts where you need the height absolutely perfect. get yourself a cheap digital height gauge, because they will come in very handy, especially if you've got like a table saw and things like that. The cutting templates are very handy. If this is your first time doing it and you've just built a nice new table, yeah, make sure that you do get one that comes with some sort of template, or you've got a way of like making your own template, because you do not want to be cutting the wrong size hole in your newly built workbench. You can see I've got a little bit of a gap here from my old DIY table that, yeah, I need to fill up. Not all of the router lifts come with these little extras, but yeah, it definitely does make life easier. Also, another thing that doesn't always come with router lifts is the various different insert plates, which if you do have under table dust extraction, like a router dust box, which I showed in that previous DIY video, these do come in very handy as well. So I'll put a link in the description to the Spetool website where you can check out this product page. Any questions or comments, please feel free to ask. But that's it for today. I will catch you all later.